Hello and welcome to the 1-3 in-class practice for track 3. I said I would do the odds, so let's go ahead and circle pages really quickly. That way we're all on the same page. Your homework would be to do the evens for this, so we don't fall too far behind. Okay, so 7, go to, where's 9? There it is. 9, 11, 13, and I believe that's it. Yep. So let's get into it. Distance and midpoint, we're going to be using those particular formulas in this particular video. BD, now we could always just count this if we really wanted to. 1, 2, 3, 4, 5, 6. It is clearly going to be 6, so BD is equal to 6. But if you wanted to use the actual formula in this, you would take the absolute value of 0.1, which is B, which is -9, subtracted from 0.2, which is D, which is -1, and that's not right. That's a 7. Whoops. Good thing I caught that. -7, and then 1, -1. And if you notice, we have two negatives in a row, a minus and negative, I should say, and we turn those into plus a positive, and we get absolute value of -6. And take the absolute value of -6, which means BD is equal to 6, as we just got. It was great. I trust you should be able to do 2. You could also verify just by counting. And let's check 3. Okay, now 3 is a little bit of a fun one. We have to find the distance, and still asking for distance, but we're using the actual distance formula as opposed to distance on a number line. This one's distance on a number line. It tells us now we have an x and a y. So what we could do here is we could actually label this x1, y1, x2, y2, just like we did in algebra. And it makes it nice and easy. So let's take a look. Our distance formula is equal to the square root of x2, which is 3, minus x1. So minus a -2. Be careful here. And then that should be squared. Plus, in parentheses, start a new parentheses, y2, 15, minus 3, y1. Don't forget the square at the end of this one as well. And let's get to work. 3 minus a -2, you can turn those into pluses. 3 plus 2 makes this 5. Make that squared. 15 minus 3 is 12. Remember, we do parentheses first in order of operations. And we still have the square root symbol here. Keep going. 5 squared is 25. Plus 144, bring the square root down, bring D is equal to down. 25 plus 144 is equal to 169. Don't forget the square root symbol. And the last step would be to find what the square root of 169 is. And that is a perfect square, meaning this is equal to 13. So this distance here is 13, okay? And that just means if I were to draw this out, -2, 3 is somewhere over here. 3, 15 is way up here. 3 to the right, 15 up. And this distance between them is 13 units. So that's what this is showing you. That's what this is saying, okay? When we're in the coordinate plane, we could actually calculate the distance. Now, for number 4, you're going to actually need number 5 a little bit because I'm going to have you use the perfect square root, or not perfect root, approximations. Take the square root using your symbol. We're not going to do absolute value roots. So let's do this. We're going to say x1, y1, x2, y2, and we're going to plug everything in. So I'm going to do a little bit of a space here so you could kind of differentiate one equation from the other or one problem from the other. D is equal to square root of x2, -3, minus x1, which is 6, square that on the outside, plus y2, -2, minus -5, which is our y1 value, and don't forget to square this as well. So, looks so far so good. -3 minus 6 is a -9. Squared on the outside. -2 plus minus a negative turns into plus a positive, which makes this 3. Don't forget to bring the square roots down. Very important. And we get D is equal to negative 9 squared is 81. 3 squared is 9. And we get the square root of 81 plus 9. Then 81 plus 9 becomes 90. And at this particular point, I'm okay if you just take the square root of 89, or a square root of 90. So just throw this into your calculator. And I don't have it. Turn this sideways. Sorry about that. I need to. Here you go. Square root of 90 is equal to approximately, so D is, this is what I meant by the approximation symbol. It is not the exact answer, but it is close, 9.49 if you round to 2 decimal places. So this is what I would do for number 4, okay? For now, I'm going to be okay with this answer. We're probably going to go into simplifying radicals probably soon. We'll see, okay? So that's number 5. Let's take a look at number 7. Use the number line to find the coordinates of the midpoints of each segment. So we're going to need that midpoint formula. So we're looking for the distance between D and G. Okay, this one is actually relatively easy, but let's actually do this. The midpoint is literally the middle point. So if we wanted to, we could just take, find the distance in the middle. Simply put, what's the difference between 8 and 0? It says 8. Cut that in half, which is 4. And if you want to, you could actually count this out. 4 in both directions. 1, 2, 3, 4. 1, 2, 3, 4. And very much like what we did with the midpoint formula in our notes, it would be 8 plus 0 over 2. And this is the only coordinate we need to solve for. And this would be 4. So that one's pretty straightforward. Here is where it gets a little bit more fun because we actually have points. Now, in this particular case, we actually need to come up with the coordinates. So we need to go 1, 2, 3 to the right, 2 up. So this is negative 3, 2. This coordinate to the right is 5 to the right, and then 3 down. And now we could do our midpoint formula. So we would do negative 3 plus 5 all over 2. So this is our x value. And then we would do our y value. So our y value, starting with this left point, make sure you start with the same point, 2 plus negative 3 all over 2. And 2 plus a negative 3 is equal to negative 1. Cut that in half. This is also negative 1/2. So our midpoint here is equal to negative 1/2 for the y. And this is going to be equal to negative 3 plus 5 is 2. Plus divide by 2 is just 1. And our midpoint is 1, negative 1/2. And you can see it lands perfectly on that line. This is our midpoint, M. Okay. Last two. Number 11. So, given IL is equal to 13, so this length here is 13, and IJ is 3, find JK, KI, and then we find blank is the midpoint of blank. So, a couple things to note. If this is length of 3, that means, let's do this in blue, J, ooh, that's terrible, to L has to be equal to 10, right? 3 plus 10 have to make that 13 for this full length, which also means we have a nice little 2 ticks, which give us a huge clue on what these lengths should be. JK, well, K, that means is directly in the middle. JK has to be halfway between J and L, half of 10, which makes this 5. And KI is a little bit trickier because we're actually going, let's say this is 5. That means this is 5. And this is 3 if you want to put a 3 here. That means from k to I is 5 plus 3, which is 8. Okay? And now we could also say k is the midpoint of JL. Okay? So use that as a reference for number 10. Let's take a look at number 13. A is between B and T. So right away, let's go and draw that. Get some kind of line. B and T are on the ends. A is somewhere in the middle. Doesn't not necessarily the midpoint, somewhere in the middle. TB is equal to x plus 13. So I'm going to do a little bit something like this. X plus 13 is this entire length. BA is 4x minus 4. And TA is x plus 5. Draw the diagram, which we just did, and solve for x and bt. So right now, we could say the part plus the part is equal to the whole, or in this case, 4x minus 4 plus x plus 5 is equal to the whole of x plus 13. Now let's check this out. Let's combine like terms. Ooh, let's put this plus in front. I don't like not doing that. So we get 4x plus x, which is 5x. We have negative 4 and a positive 5, which makes us plus 1. We get x plus 13 here. Bring the variables to one side. I personally would keep them positive. And then if you want to, you can knock this over to the right side really, really quickly. And we get 4x is equal to 12. Last step, divide by 4, divide by 4. X is then equal to 3. But we're not done because it says solve for BT as well. Okay? Now BT is this x plus 13. And we know what this is now. X is equal to 3, so it's 3 plus 13. BT is equal to 16. We're done for A. B. Is A the midpoint of BT? Well, we could find out. What we would do is we would plug it in and see if it works out. So for instance, BA is equal to 4 times x minus 4, and 4 times 3 minus 4. 4 times 3 is 12. 12 minus 4 is equal to 8. And B is equal to 8. Now, we know that this distance is now 8. We know the entire distance is 16, which means this distance would also have to be 8, which is true because if you plug in a 3 here, 3 plus 5 is 8. Thus, A is the midpoint. They are both equal on both ends, it cuts it perfectly in half into 2 equal segments. What is the midpoint? And we're done. So, for 14 and number 12, you should be able to do something similar. Okay? If you have any more questions, please send me an email, ask. I'll be back on Tuesday and the rest of the week. Other than that, have a good one. I'll see you in the next one.